Welcome to Pythagoras Theorem, the Coastal Academy way. Now, many years ago there was a man called Pythagoras. People thought he was a mystic because he had such strong mathematical abilities, and people followed him and they followed him and they called it the Pythagorean Brotherhood. This was 2,500 years ago, but still we learn about him in school. Now, he's going to come up in your exam and I'm going to show you how you're going to answer the exam questions. First of all, I'll introduce you to him. It wasn't this man, Plato, or Aristotle, or Socrates, all good-looking men in their own right. He was the big chunky fella with the bald head at the bottom. Very intelligent man, concentrated on his maths more than his looks. Now, if we move this way, we will see an example, and I'm going to talk to you about the theory that he came up with. He discovered if you take any right-angled triangle in the entire world, and you know two of the sides, you can work out the third side. And this is the way you do it. First of all, we have a right-angled triangle here. We have the missing length, which is the long side. Now, he stated this. If you square the little side and add it to the medium side squared, you get the square of the third side, the longer side. So, 9 squared plus 12 squared gives us x squared. And we can carry on a little bit further. 9 squared, 81, plus 12 squared, 144, will equal x squared. If we then add these together, 81 and 144, we get 169 equals x squared. Now, we don't want to necessarily know what x squared is. We want to know what x is. So therefore, we have to do the opposite of squaring. The opposite of squaring, something to do with trees, square root. Let me just write that down. The square root of 169 is equal to x. If you work that out on the calculator, your square root button, plus 169, gives you 13 is equal to x. Now, always make sure you stick your units in. If we've got centimetres there, the answer is 13 centimetres equals x. Then always check, is your answer sensible? If this is 12 and this is 9, does that look like it could be 13? I think it probably could. Therefore, it's correct. That is the first way of working out Pythagoras with your correct working when you're working out the longer side. Let's move over here. Well, a similar scenario, however, there's one thing different. We know the long side, and it's 26 metres. We know one of the shorter sides, and it's 10 metres. How can we use Pythagoras' theorem to work out the missing shorter side? First of all, I'm going to write Pythagoras' theorem down, just so I get to grips with it. He said 10 squared plus, I'm going to have to put t squared, equals 26 squared. Now, some of you very, very quick mathematicians, as bright as Pythagoras, will notice I can rearrange this. So actually, if I want to, I can keep the t squared where it is, and that will equal 26 squared, take away 10 squared. So what I've now got is the equal sign with the t on that side, and I can work this out, then get down to my answer. So I'm going to do that for you. T squared, therefore, will equal 676, take 100. So t squared is equal to 576. Now, I can then step back and I think, okay, I'm quite happy with that. And I can write down t, therefore, is equal to the square root of 576. If I get my calculator and I work out the square root of 576, I would find that t is equal to 24. This time, metres, because our units are metres. That is the other way to work out Pythagoras, when you know the long side and you're trying to find one of the shorter sides. Good luck at your tests.